Okay, let's get started. Welcome everyone to this webinar where we are going to talk about how artificial intelligence can support sustainability in manufacturing. The speakers that we have today are Jonas Forsman. He's one of our consulting expert directors, data scientist working a lot with implementation of AI. Myself, working mainly with information management as a business consultant, also together with Jonas and Simon, one of our competence leads for artificial intelligence within CGI. We have our guest here from Uddeholm, Ola Axelsson, who is a manager for products and engineering at Uddeholm, who will be speaking about one of our customer cases today. We have Simon Tofteberg, our colleague from Norway, also working with data science and artificial intelligence, implementing a lot of different solutions for our customers, and he will be our second speaker for the customer cases that we will be presenting to you today. And we also have Sara Carmo e Silva, who is Director Consulting Services for Business Consulting, who will help us moderate things and take your questions and so on. So once again, welcome. And this is what we will be covering today in the webinar. I will start by saying a few words about artificial intelligence and sustainability in manufacturing to set the frames, sort of speaking, before we go into the different customer cases where we will share with you some information and experience of things that we have actually done for customers. We have two cases to present, one from the steel industry from Uddeholm, and then we have a second one from NDT Global, used to be called Halfwave, which is in oil and gas, which Simon will present. It's a case from Norway. So that's the plan for today. We will round up with a summary at the end, and then there will be time also for you to ask questions for us. So we encourage you to ask questions, and please write them in the chat. We will collect them and try to answer as many as we can at the end of the webinar. So let's start then with a few words about AI and sustainability and see how that can be used in a manufacturing context. So to start with, what do we mean by artificial intelligence? Since this is a multidisciplinary field of research spanning not only computer science, but also philosophy, psychology, neuroscience, economics, mathematics, and a lot of areas, it's not very easy to find a definition of what we mean by artificial intelligence. But the one that you have here, which states that the field of artificial intelligence is concerned with not just understanding, but also building intelligent entities or agents, machines that can compute how to act efficiently and safely in a wide variety of novel situations. This one is taken from the standard textbook on artificial intelligence by Russell and Norwig. So that's what we mean when we talk about artificial intelligence in this context here. And if we look into specific areas that we address with artificial intelligence, we have learning and probably be this area with machine learning and deep learning and reinforcement learning and so on is the key to why we have had this hype around artificial intelligence during the last few years. Especially deep learning has proven to be very, very successful, and that's why there is all of this talk right now about AI. But that's not the only part that we need. An intelligent agent also need to be able to interact with its environment. So we have cognitive functions and communication functions as well, with computer vision, speech recognition, and natural language processing, and so on, to be able to perceive things happening in the environment and also communicate with other actors in the environment. And also to be able to act in the environment, we have robotics, or embodied artificial intelligence, where an AI solution then can act with its environment. And if we look towards the future, today we have narrow AI solutions mainly, but if we look towards the future, the goal is to improve intelligence over time, and we are talking about artificial general intelligence, that is human level intelligence, when an AI solution can actually perform at the same level as a human. It's debated on when or even if we will reach that, but that's the target, and most people, most researchers think that this is something that we actually will achieve within this century. So, do we have any limitations when it comes to artificial intelligence? Well, basically it's your own imagination that sets the limits, because you can find applications for AI, to use AI as a tool in almost anything that you can think of. And then the second part here is that we need to have a lot of information, a lot of data, to be able to feed these algorithms that we have in AI, especially the machine learning algorithms are dependent on big data. So data is a key also here that you need to have control of. You need to have information management in place. You need to have data management in place in order to secure that you have a good foundation for the AI solutions that you will be building. And as we mentioned also, we have today narrow AI, which has a limited scope. It can go very deep and perform better than humans, but still it's in a limited area which we build tools today. But as we saw, this might change in the future if we get to a position where we have artificial general intelligence. And on top of this, today also there is a lot of talk about responsible and ethical, or even sustainable AI, and how we can deal with that. How can we deal with bias in our data sets? How can we deal with automatic decision making happening by AI algorithms, and so on. And we also have now recently, since just about a month back, a proposal from the European Union for a regulation for artificial intelligence, the Artificial Intelligence Act, which is now up to member states to decide on if we're going to make it into a law. So that's another thing that can put limits on what we can do with artificial intelligence. So sustainability, what do we mean by that? This definition here is taken from the Brundtland report from '87, Our Common Future, and it's the sort of the standard definition for sustainability. So what we say is that sustainability means development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So that's what we're talking about when we talk about sustainability. And of course, we also have the United Nations that are working with questions and challenges around sustainability. We have the 2030 agenda that has set up a number of goals for sustainability. I picked out a few of them here. And as you can see here in the first one, it's not just about the environment and the climate. It's also aspects, social aspects and economic aspects as well, that goes under the umbrella of sustainability. And then we also have some which are more maybe related down to manufacturing here. goals that we have in this 2030 agenda program from UN. But I will not go into any details on them. There is a link here so that you can find them after the webinar when you get access to the presentation. If we look at manufacturing specifically, then there are a few things that we focus on. So resource usage is one thing. How do we source resources? How do we secure that we use them efficiently? We have waste, which we will be hearing about in one of our cases here today. How do we limit wasting these resources that we are using so that we take care of as much of them as possible? Another key thing in manufacturing is the usage of energy. How do we make that usage as efficient as possible? And finally here also impact on climate, where we talk about emissions and preventing leakages of things out into nature, for instance, which we will also hear about in our second customer case here when we look at oil and gas and how we have used AI there. So if we try to link then artificial intelligence and sustainability for manufacturing, how do we do that to start with? Well, there is a lot of talk about Industry 4.0 in manufacturing and how will AI fit in there. We have wireless communication between machines. We have a lot of sensors. We have automation in the process for producing things and so on. And all of this that we have here related to Industry 4.0 will generate a lot of data. And as we saw previously, data is one of the key things that we need and one of the things that can be limiting for what we can do with AI as a tool. So we have data coming there, but what should we use it for? So we have a number of specific use cases related to manufacturing. The list that you have here has been taken from a report, a Swedish report called Artificial Intelligence Within Manufacturing. And as you can see here, we have use cases around quality and process control, predictive maintenance, identification of material characteristics, logistics optimization, production planning, and also adaptive motion control for robots so that they can actually adapt how they move during the processes and so on. And if we look then to the challenges, and specifically here, we are looking at the steel industry. In manufacturing, we have, as we mentioned before, the emission part, how to deal with that, the resource usage. In steel, we have iron being used in a lot of the production. We have minerals, we have limestone and so on as resources. We have fuel and energy challenges here for production. There's a lot of heating going on when you produce steel. So there's a need for both electricity, oil and gas. And we have transportation, both internal and external, that we need to address how to optimize to minimize emissions and so on. And if we look at this, quality and process control, of course, can address how we use resources, how we use energy and fuel in the best way. And we have logistics optimization here that can address how we do transportations in manufacturing here. Okay, so that's a few words about AI, sustainability, and manufacturing. And now we will move over to our actual customer cases so that you will get some information and experience that we have had here. And I will pass the word to Ola Axelsson from Uddeholm.
Okay, thank you very much. My name is, as Raymond said, my name is Ola Axelsson, and I work as an engineering manager at Uddeholm. I will talk a bit about what we are doing in the field of AI, and I will give you some examples and also some specific case which we have made together with CGI. And of course, when we look at sustainability, this is a very, very hot topic for us at the moment, and especially when it comes to energy and fossil freedom, but also to when it comes to resource utilization in general. So this is a very hot topic for us at the moment. At first, just some quick introduction to Uddeholm and what we are doing. We are a tool steel manufacturer, and we are manufacturing steel for tools like the ones you see in the picture here. It could be tools for forming a plastic bottle. It could be tools for making sunglasses or a mobile phone, or parts for a car or whatever. Everything you need to shape, you need to have a tool for, and hopefully that tool is made in our steel. And important factors in this kind of steel is the cleanliness in the steel, and the polishability of the steel, and the strength of the steel, and so on. So quality is a very important factor for us in our steel making. Here we are located in Hagfors, which is a small city in the county of Värmland, and it is just in the middle of Norway and Stockholm. And here in the middle of the forest, we have this plant, as you can see in the picture here. We work here, we are 850 people working here. We produce about 60,000 tons of tool steel every year, which we sell all over the world. We are represented in more than 80 countries, 90%, more than 90% goes on export. Our annual turnover is about 300 million euro. So we are a global steel company. This is in the next slides. I will show you some information about the project. Actually, it was one of the first AI projects we made, and this one was together with CGI. And we wanted to find we wanted to understand why we have cracks in steel, basically. And also one purpose of this first project was that we wanted to see the potential in AI. What can it do for us? Is this something for us to go for? So I will show you some things about that. At first, just some quick introduction to the process of steel making. We are a 100% scrap-based steel plant. That means that we are basically a recycling company, because we buy scrap and then we melt it in the electrical arc furnace, and then we make some metallurgical magic on it. We put in the right alloys and we make it cleaner and so on, and then we cast it into ingots, and after that we take it. We could do more cleaning operations of the steel in electroslag remelting, or we could go directly into forming. And in this forging press or the rolling mill, we are making the shape of the steel. If it should be a round bar, if it should be a rectangular or a square bar or whatever. And the next step is that we want to heat treat the steel to have the right properties, the right hardness, and so on. And after that, we have just some machining operations and also some quality inspections and so on. And then we cut the material in the right dimension and send it out to the customers. So that is basically a very simple explanation of how you make steel. So in this project, we wanted to find the root cause to why we have cracks in the steel. As you can see in the picture here, this is a typical crack that we can have in the steel. And when these occurs, we need to cut off this piece and put it back in the electrical arc furnace and remelt it once again. And of course, this is very expensive and it's time consuming, and we use a lot of resources and energy and everything like that. So this we want to avoid, of course. So what we did in this project, we selected 2 steel grades, and we gathered all the data we had in our data storage and tried to see if we could find any parameters or combination of parameters that affects the upcoming of cracks. And of course, what we wanted to see is, and we wanted to get is, in some way, if we could adapt the process to avoid these cracks from occurring, and also to learn more about what the value of data is. So that was the main purpose of this project. So this is a picture showing the steel mill. I don't know if you have been in a steel mill before, but it's very dusty, dirty, very high noise, it's very hot, and so on. And this is the electrical arc furnace where we melt all the steel. And but we gather a lot of sensor data, and a lot of data are stored all the time. It could be pollution control, power consumption, temperatures on the steel, chemical composition of the steel, the weight we are pouring into the ladles, preparation times, and so on. In the next step, we are putting the material into a furnace to get it into the exact right temperature before we squeeze it. And in here we have also a lot of sensor data. It could be the temperature in the furnace, the pressure in the furnace, the energy consumption, NOx values, and also we track temperature in the bars. And it's a lot of data we collect also in this operation. And the next step is the forging press, where the material gets its final shape. Also here we gather a lot of information about power consumption, temperature control, manipulator movements, contact time of the material, pressure, and everything like that. So it's a lot of data that we store for all these operations. So what we did in this project, we looked at all this data from these different sensors and everything. And we wanted to find if there is any parameter or combination of parameters that affects the cracks in our steel. And what we found, it was a lot of, it was Jonas Forsman, the guy in this meeting who helped us with this. And we find a lot of interesting things. One thing was that if one of the alloying element was within a certain limit, and that in combination with the time of the forging press, when that exceeded 5,000 seconds, then we had 87% risk of getting cracks. And this finding was a typical thing that was really an eye-opener for us, because Jonas Forsman has no experience in making steel, but he could tell this important thing just by looking at the data. And this would, I mean, to find these things with conventional process development methods, it would have taken years to do this. So this was a really eye-opener for us. This is very, very interesting. So then some takeaways from this project was that we really understood that data has a great value, and we really need to ensure that we have high quality in our data. And we need to set up a data governance model, which we are doing right now. We have a data management project. I will come back to that later. And we also understand that we need to have a future-proof infrastructure, a platform where we can handle both batched and streamed data, because we want to have these in real time instructions to the operator, how to adopt the process and how to act in order to get the best yield of the material, or to reduce the risks of getting cracks or what it could be. So here is the infrastructure we have set up to now. Basically, we have in the bottom here, we have all the sensors. This is a milling machine, and here we have a furnace and a forging press, but it could also be data from the databases, or it could be data from smart sensors, or it could be images or videos or everything like that. We gather this all in our Kafka cluster. Then everything we do revolves around this Kafka cluster. We could send the data out from the Kafka cluster up to our cloud. And in here we do all the training of the machine learning models and all the data analysis and so on. And here we develop the models, and we then deploy them closer to the operators, so they can have in real time recommendations of how to treat the material at that moment they're handling it. But we can also have conventional dashboarding or just to pick out the data we want to have, because everything is in this Kafka cluster. So this is a really good thing that we have made so far. One other important thing that we learned, we really need to treat data with as something of value. So as I said before, and this is a project we run now together with CGI. We want to have set up a data governance structure in order to be sure that we really have control over data, to know that their data quality is high enough. We also want to set regulations on the data, like definitions. What is the KPI? What is the data? And also standardize the naming of all the data, and also make classifications on the data and so on. And then we also want to have a data catalog where we can track all these things, where we can where we gather all the things. It's just a tool to handle all this the data management system, so to say. Here I just wanted to mention 3 more such use cases. The first one was to find cracks, but we have a lot of other use cases going on and projects going on, but here are just a few examples. Then we have one here as an example for predictive maintenance. There is, in one of these furnaces, we want to have an optimization between energy cost and maintenance cost. So we want to, in this case, the machine learning model tells us when it's optimum to do the maintenance on the burners in the machine, in the furnace, in order to get the right energy values in combination with the maintenance cost. So this is a really success as well. Second thing is we have set up an in real time automatically detection of compressed air leakages in the system. This is also a machine learning model who can detect when we have leakages in the compressed air system. And compressed air is, I don't know, but it is a very expensive energy form of energy, basically. So this is also where we save a lot of money. Process improvement, this is a third use case that is in one of our ESR furnace. When we make the preparations for an ESR furnace, you need to vacuum pump all the oxygen out from the furnace and then replace it with argon. But this vacuum pumping, sometimes it takes very long time to get in the right pressure. But with this machine learning model we have in this application, we can, after 1 minute, tell if we're going to reach the right level in time, or if we need to close the machine to do the maintenance. So in this case, we save a lot of setup time with this model. One other thing, this is a complete different topic, but is one success factor for us has been the way we organize around the work with AI and so on. We have this organizational concept which we call hub and spokes. And basically it is a hub where we have the data scientist, we have the data engineer, and we have the experts in AI and I would say IT infrastructure in here. And we combine these guys with the domain experts, and those we call spokes. The domain experts could be from R&D, from production, logistics, or whatever. And they tell which use cases we should work on. And in order, this concept allows us to, in this way, we know that we're really working on solving actual problems, that is problems that we really need to solve and where we can benefit from. In the beginning, all the projects we started from the hub, they were just more of fun case. I mean, in this way, we can do some real changes that really affect some problems we really have. So this is a very good concept. So, and just the final slide from my side, it's I want to show you our 3 focus areas when it comes to digital transformation. We want the company to be data driven, of course. We want to make decisions based on insights from data. That is one thing we work a lot on. And we want to have this inclusion. We don't want this to be a separate team working as an alien or something. We don't want it to be an own department. we want this work to be included in your daily operations. This should be something, a tool that really are used. And this we reach through our hub and spoke organizational concept. So this is basically that. And then the third focus area is change management. And here, of course, we make a lot of training on the management in change management methodology and so on. And we also have this, what we call Auto Digit Academy, and that is automation, digitalization, and IT academy, where we want to increase the competence in all fields, from ranging from operators up to data scientists. Everyone should take a step. So this is what we're aiming for in this focus area. So I think my time is up. That was what I was thinking of.
Okay, great. Thank you, Ola. So then let's go to our second customer case then, NDT Global. And here it will be Simon that will be presenting.
Yes, thank you, Raymond. I will start with present myself. I'm working in Insight and Analytics in CGI Norway. This is the department focusing on big data and machine learning. I've experience with AI in industries such as manufacturing, healthcare, and oil and gas. And I'm passionate about the potential in AI to solve sustainability challenges for our clients. So NDT Global is our second case for this webinar. The company is a leading supplier of pipeline inspection tools. Their skilled engineers are analyzing pipelines all over the world and delivering inspection to oil and gas producers mainly. CGI was engaged with an AI and machine learning team to help improve the data analysis in NDT Global. So let's start with a question. How can the oil and gas industry try to become more sustainable? Sustainability and oil production may not be the most likely combination that comes to mind. The negative aspects that can come from activities carried out by oil and gas companies can have severe impact on both the community and the environment, such as pollution and spill, as well as the ongoing danger of working with those resources. We are living in an increasingly eco-friendly world, and manufacturers are adopting and implementing green practices for both a safer living and working environments. Oil and gas companies recognize the need for a more sustainable and environmentally friendly production to reduce the footprint of the industry, and are going new ways to minimize waste and increase safety of the production. When producing oil and gas from a field, it needs to be transported to customers. On many oil fields, oil is loaded directly onto tankers. In other cases, oil and gas is transported by pipeline. In Europe, oil, wet gas, and liquefied natural gas are transferred to ships at onshore facilities, while dry gas is usually moved by pipeline to the UK and continental Europe. In the US alone, there has been more than nearly 300 pipeline-related accidents on a yearly basis between 1986 and 2013. This has caused roughly 200 spilled barrels each day in the same period, which hurts not only the environment, but also wildlife and communities with pipelines present. In Europe, there has been nearly 1,200 recorded incidents in pipeline failure from 1974 to 2013. The top reasons for pipeline spills and leakages include damage during excavation operations, metal failure, and corrosion. NDT Global is developing inspection tools to try and prevent these kinds of environmental catastrophes and make way for safer pipelines for communities and for the preservation of Earth. So NDT Global, they have developed an internal pipeline inspection solution that performs direct wall thickness measurements in high pressure gas pipelines. The robotic inspection tool travels inside the pipelines from one end to the other while mapping the inner and outer walls with acoustic resonance technology. Acoustic waves are sent out from the vessels, and echoes from pipe walls are captured and used to digitally reconstruct the pipeline for data analysis in order to see the conditions of the pipelines. This can be performed in both gas and liquid domains. Before CGI was engaged, the data analysis was done manually by analysts scrolling through the pipeline centimeter by centimeter before delivering a report to the oil and gas producers about the condition of the pipelines. This was a costly and slow procedures. Many of the pipelines can be between 100 and 1,000 kilometers long. CGI helped build advanced anomaly detection algorithms that can detect pipeline defects, such as cracks, corrosion, and geometric deformation with increased accuracy. This meant that NDT Global are able to do the data analysis in just a fraction of the original time, reducing cost of doing analysis greatly. In the first delivery, this was a semi-automatic system with human Q&A. But the goal is to eventually deliver a fully automatic report to oil and gas producers about the conditions of the pipelines. So as a result of this project, NDT Global are able to find defects with higher accuracy. They have an objective method for doing defect detection. And what's considered a defect is more of an objective understanding than before. It has increased the efficiency of the analyst department, which make them do more. It has also some social and environmental benefits by reducing risk of negative impact on local communities and decreased risk of spill and pollution of the eco environments. So Raymond, would you like to summarize?
Yeah, thank you, Simon, for that. Okay, great. So we've heard now two of our customer cases that we have been working with here at CGI to use AI as a tool to address different sustainability challenges. So, of course, things are happening fast in AI. So as we move forward, there will be more opportunities to find ways to utilize AI as a tool for different sustainability challenges that we see, not only in manufacturing, but in general as well. So AI will definitely be one key tool to address these challenges that we see. And well, basically, when it comes to AI, you saw previously that we have a number of different use cases. We have a lot of challenges. So it's just a matter of getting started and start to experiment and to learn how AI can be used and apply for sustainability challenges. And one key thing here also to to take away is that there is no real conflict between using AI to address sustainability challenges and business objectives, because if we can optimize the way we use resources or limit the waste that we have in our processes and so on, then or the energy consumption, then there is of course an economic gain to be had here as well. So this is definitely an area to be explored further. Yeah, we thank you for your attention here today, and let's see if we have any questions. So we have one here. What does the business case look like for the use cases implemented so far at Uddeholm? So I guess this one is for you, Ola.
Sorry, could you please take it once again?
Yeah, what does the business case look like for the use cases that you have implemented so far at Uddeholm?
Yeah, they are, of course, we have made a lot of use cases, but I would say they are really, really looking good, because of course, we had a lot of cost setting up the infrastructure and so on, but now we are ticking off this quite fast, because when we have all the data connected to this Kafka cluster, it's quite fast work to do the data scientist work on it to get. So the individual use cases from now are really fast, pays off really fast, I would say. So now it's really fast when we have this infrastructure in place. So I don't have any number to give, but it's quite a good business cases on these use cases for sure.
Mm. Thank you. Anyone else from the audience that have more questions for us? If not, maybe then.
I think we have some more questions.
Okay.
Ola, what was the trigger for Uddeholm to start experimenting and applying AI in production? Was there any critical point in time or something that happened? How could you, I mean, you have done several use cases, so what was the trigger?
Yeah, actually it was, I mean, it's quite a large hype around this, and we learned that this is something we heard about it all the time, and we really wanted to try something. And we also get in contact with the guys, so Jonas and the guys from CGI, and we were sat together to try to find the best use cases. And I think we came up with the 7 or 8 ideas already at the first meeting, where we really saw that the potential could be there. But we decided for this crack case as the first one. So that was the story behind it. So it was that, but it was also increasing the focus on digitalization in general in our company. We belong to an Austrian steel company, First Alpine, and the focus there was stronger and stronger. So that evolves from that, I would say.
Another questions. Thank you, Ola. Another questions then to Jonas or Simon here. What has been the most challenging part of the project in your roles that you have had as data scientists? Maybe Jonas could start.
Yeah. Hi. Yeah, I would say that the data quality is always high up on the list. How do we make sure that we have a good quality of the data and that we have enough data and that kind of questions? That's always difficult, and it's very necessary to address those questions.
I think I will have to say the same thing, the quality of the data and also the amount of data. For example, for pipelines, there is a lot of pipeline data, but there's a lot less actual defects in the pipelines.
Thank you. And another question here related to the NDT case. have you done any predictions also? Because you use AI for inspection, but could you predict where defects will occur in advance?
We are primarily right now using predictions to try and predict what kind of defect that is occurring. So, for example, if the defect is just a weld seam, which is supposed to be in the pipeline, and so on. I think in the future, it would be nice to see if we also are able to predict the defects in advance of doing the inspection of the pipelines.
Thank you, Simon. And here is one more question to you, Ola. What was the main difficulty passing from a simple POC to a real-time solution in production?
Yeah, of course, steel business is it's a long tradition. We have people been working here for a lot of time. It's a lot of old knowledge, and when this comes in, it's quite difficult to get something new in here. So I really think we had a strong team within Uddeholm who was really eager on this this technology. Who were, I would say, we were like ambassadors for driving this. We were a couple of guys, 4 or 5, on management positions. We really think that this was something beneficial. So we drove it forward. I think that is a key, to have those strong persons in the organization in order to take it forward.
Thank you. Then I have one question to maybe to you, all of you, but well, critical success factors if you want to succeed with implementation of AI solutions. Do you have any good advice? No one wants to start.
Okay.
Jonas?
Yeah, I can. I would say that, and we have touched on it several times, the data quality, but I would also say to have a chief data officer that is empowered to actually take action. This is a role, a position that is very difficult in almost any company, and it requires quite a lot of experience and to actually act in this role, I would say.
Okay, thank you. Someone else who wants to add something to this question?
Yeah, I think one thing that you shouldn't forget, which we were talking about previously also, is the responsibility and ethical aspects, that you actually take those into account from the start, so that it don't end up as a surprise at the end.
Do you and then maybe the last question, I think that we don't have any other. Yeah. Where do you see the biggest potential if we are talking AI and sustainability? From your point of view, where can we find potential areas or applications that could really support our sustainability goals? You have shared now 2 cases, and Ola, actually you had several cases, but what do you see? What could be the next step, or where do you see the potential? Someone want to comment on that?
From our side, I would say it's connected to energy, of course, because it requires a lot of energy to produce steel. So when it comes to energy, we have a lot of things we can do with AI. And we have a lot of ideas already. And also connected to energy, we had all the conversional problems when we want to go from oil and gas and fossil fuels into electricity. Then we get new problems for electrical grids and so on. And to predict the loads in electrical grids, that is something, I mean, it's not directly connected to sustainability, but it's an important factor to make it possible to be more sustainable. So
Yeah.
there are two areas we are focusing on, at least.
Thank you. Someone more that wants to comment on this?
I will probably also add operational planning.
Yeah.
AI can be used to plan the operations and to reduce both spill and waste from production.
Yeah, to optimize then the production processes. Yeah, good. Thank you. Thank you for sharing all your insights in this area with us. So I think that was our last question.
Okay, great.
Yeah.
So then let us wrap up. Thank you all for attending this webinar. You will be receiving material afterwards. The webinar has been recorded. You get a link to that, and you will also get the slides. And if there is anything that you would like to ask, that you come up with any questions after the webinar, you have all of us here and all of our contact details here, so you can get in touch also after the webinar if there is anything that you would like to ask or talk about. So thank you all for attending. Bye bye.
Thank you.